So let's say after this data is collected by the satellite, we want to display it so that we can look at it in the GIS. How would we go about doing that? Well, we have 7 different layers that are all photographs, are all images, so we can't really display all 7 of those at the same time in the same area because of course they directly overlap. We can display as many as 3 of those at the same time, and I'll talk about that next. But what I want to talk about first is what if we just want to display one of these bands and we want to see how it looks? Well, what we can do is we can just pick one of the bands. So in this example here, here's one with 7 down here, but let's look at this one up here. There's one called Spot. It's a French satellite that collects panchromatic imagery from the green and red portion of the electromagnetic spectrum. And panchromatic just means it doesn't really have any color associated with it. It's just trying to collect as much data as it can. It's collecting from more of the electromagnetic spectrum, so it can collect at a finer spatial resolution. It can get down to 10-meter resolution, whereas most spot imagery is twice that. So let's take a look at what that looks like. This is a spot image. And basically, we're just displaying this as a single band, and we're doing it in black and white. So basically, there's no real color associated with this because it's reading from different portions of the electromagnetic spectrum. So we're just using shades of gray in order to display this image. And how do we actually do that? Well, we can actually, if we're using 8-bit data, what 8-bit data means is that we have 2 to the 8th different values that we can have, or 256 different values. So we just display that in grayscale as a series of grayscale, starting with black is equal to 0 here, and white would be equal to 255. And even though it's difficult to see, each one of these is changing by just a little bit in grayness as we move between those two, kind of back like that and then over like that again. This is traditionally what we use because 256 is 1 byte of data, and that's just traditionally what we use for display. It probably wouldn't do much good to display with more shades of gray because it's difficult to even see the variations when we have 256 shades of gray. So basically what we can see here is that each one of the pixels in this image gets some shade of gray, and we can look at that in the image itself, or we could look at it as a histogram. A histogram shows the brightness value varying from 0 to 255, and it also shows how many times those different values occurred. So in this example here, maybe this range around 128 occurs the most. Probably if this were really true, we'd have more of the black because water shows up as black, so there would definitely be some ones here, kind of a spike at the end of the black to represent the water. But this would be an example of how to display a single band of satellite imagery. We could use shades of gray or shades of red or shades of blue or shades of green, but typically these are shown with shades of gray, and we can look at it either as an image, which shows it spatially and where the different components are, or we can look at it as something called a histogram, which shows how frequently each of those shades of gray shows up in the image and plots it as a bar graph.